Okay, this is the interior designer question where a lady wants to put this design on a computer, and it's for a bathroom tile, and it says that the height of this square tile is 20 and the width is obviously 20, and the diameter of the circle is 18 centimeters, and the point A where the hyperbola meets the diagonal line is 2 root 5 above and 2 root 5 to the right of the center of the tile. Okay, so we're going to come up with all the functions involved that makes this tile visible. So let's start with a square frame. And if this here, we're going to mark it as the origin, then these horizontal lines, top one and bottom one, would be 10 centimeters above the origin, and this would be 10 centimeters below the origin. So y is equal to 10, y is equal to negative 10. Okay. Likewise, with the vertical lines, this would be 10 centimeters left of the origin, and this would be 10 centimeters to the right of the origin. So x is equal to negative 10, x is equal to 10. So that's the square frame. Let's now do the diagonals. Formula for a straight line is y equals mx plus c, where m is the gradient, and the gradient is rise over run. And what's the rise and what's the run? Well, if we start at this bottom left corner and went up 20 and across 20, our rise would be going up 20, our run would be going across 20, which makes 1. And it makes sense that the gradient is 1 because this is a 45-degree angle. Okay. What is the c value? Well, the c value is always the y-intercept, and it goes through the origin. So in this case, c is equal to 0. So we have our equation to be 1x plus 0, which is just x. Now, likewise, if this is y equals x, well then this diagonal line would be y equals negative x. And, well, the rise would be going down 20, the run is still across 20, so we would get negative 1 for our gradient. It still goes through the origin, so our c value would still be 0. So that confirms what we already have. So that's the diagonal. Then we have the circle. Formula for a circle is x minus h squared plus y take away k squared is equal to r squared, where h and k is your horizontal shift and your vertical shift, or otherwise known as our center. And our radius is r. Okay, I'll just make note. Center, hk, and radius r. Okay. So because the center is 0, 0, h is 0, k is 0, so this is going to be x squared plus y squared is equal to the radius, which is going to be 9, half of 18. Okay? So that's our circle. With center 0, 0. Okay. Let's now work towards the last function, which is the hyperbolic function. And the formula for a hyperbola is y is equal to a over x minus h plus k, where h is your horizontal shift, and k is your vertical shift. And likewise, from our diagram, there is no horizontal shift upward, and there's no horizontal shift either to the left or to the right. There's no vertical shift upward, or else it would look like this. Let me try that again. Okay, so if that was the function 1 over x, then to add a value of k, let's just say it's 5, we would get that. And or if we had 1 on x again, a horizontal shift, so let's say it's y is equal to 1 on x plus 5 this way, then the shift would be to the left, and we would get that. Okay? And because the tile is completely symmetrical, and it says that in the question, we know that h is equal to 0 and k is equal to 0. Okay? Which leaves us with the value a, which we're still unawares of. Okay? But we are given a coordinate on this hyperbola. We're given capital A is 2 root 5, comma 2 root 5. Okay, so what can we do with that coordinate? We can plug it in and see if we can solve for small a. So when x is 2 root 5, y is 2 root 5, and we can solve for a now by rearranging the equation, moving the denominator to here. We get 2 root 5 squared is equal to a, and 2 squared is 4, root 5 squared is 5, a is equal to 20. So our final function for the hyperbola is 20 over x. Okay, so that's the last function on here. We have them all now. The last thing to do is to denote the domain and range. Okay. So, starting with the square frame, y is equal to 10. Y equals 10 is a line that continues forever, negative and positive. And so we need to restrict that domain to negative 10 and 10. So we'll say that the domain here is no greater than 10, no smaller than negative 10. Likewise for the second horizontal line. For x equals negative 10 and 10, that's stretching this way. We have to restrict that range to negative 10 and 10. So we're saying that the range y is being restricted. For the diagonals are going in this direction, so the domain and the range for both cases here, they each go on a domain from negative 10 to 10. And the range as well is negative 10 to 10. The circle stretches as far to the right as 9 and negative 9 to the left. So the domain here would be negative 9 to 9, using square brackets, which means inclusive. And the range talks about how high it goes. That's also negative 9 to 9. So it's quite nice that this question is fully symmetrical, makes it easier. The hyperbolic function also, as high as 10, as low as negative 10, as far left as negative 10, as far right as negative 10. So the domain and range is negative 10 to 10. And that's it, we're done. So good luck with your questions.